This tutorial represents a hands-on exercise for merging pairfam data in Stata. You will be guided through the process of matching the pairfam datasets based on a given research question in order to prepare a dataset that enables you to analyze this question. The research question is: do children whose parents have higher education level, in German Hochschulreife, obtain better grades in math? The aim of the matching process is to prepare a dataset for pooled cross-sectional analysis. This means that these questions might have been asked in several waves, and I want you to merge data from several waves in long format. Take a moment to write down this question and think about where you would start. Please pause this video tutorial now and think about your next step. As you will remember, the first step in the matching process is to identify the variables, datasets, and waves in which relevant variables are stored. You might find the variables for answering this research question in the parent and anchor datasets or in the anchor and child datasets. Please be aware that the variables for the different respondent types are stored on separate Excel sheets. Pause the video tutorial now to open the question program and search for the appropriate variables. Have you found the appropriate variables? Children's grades in math are included in the child datasets for waves 2, 4, 6, 8, 10, and 12, with the variable CDU4I1. In the anchor datasets, you can find the variables SD32I1 to 13, which store the highest educational level the anchor respondent has attained since the previous wave. However, it is easier to use the generated variable school, pre-prepared by the pairfam team, to simplify your research. As you may remember, the generated variables are also stored on a separate sheet in the question program. Before we start with the matching process, we must consider which identifiers are needed to match the anchor and the child data from waves 2, 4, 6, 8, 10, and 12. As you already know, each dataset contains the anchor identifier ID and the time variable wave. The children identifier CID might also be useful to identify the anchor's children if more than one has been interviewed. However, CID is not absolutely necessary for the matching process. Now that we have identified all relevant variables and datasets, you can open the Quick Start Matching, which will assist you in the matching process. At the top of the Quick Start, you will find an overview of combinations of datasets and corresponding examples. For instance, if you want to combine the anchor and child data in wide format, you will find an example in section 2.3. Pause this tutorial now and try to match the anchor and child data from waves 2, 4, 6, 8, 10, and 12 with the help of the Quick Start Matching. There are several ways to match the datasets, depending on your starting point. We will cover two different approaches. After you have defined the data path where the data is stored on your computer, you can begin. One approach to matching pairfam datasets is to always start with the anchor data. The first step is to merge the anchor with the child datasets. One option is to define a loop to run the following for waves 2, 4, 6, 8, 10, and 12. Please note that the wave 12 data is stored in two datasets, one for KP respondents and one for KT respondents. To do this, open the variables ID, wave, and school from the wave 2 anchor data with the command use ID, wave, school using anchor, wave, clear. Then merge one anchor respondent to many children using the child data from wave 2, keeping only the variables CID and CDO4I1. Afterwards, tabulate the automatically generated variable -merge and keep only the cases that were able to be matched. Anchor respondents without any child interviewed are therefore excluded from the analytical sample. The variable -merge can then also be dropped, and the merged dataset saved as math2. This same process will loop automatically over waves 4 to 12. Now all we need to do is append all the waves of merged data. Open the dataset math2 and append the datasets for waves 4, 6, 8, 10 and 12. Afterwards, sort the data and check the browser to see whether the matching process was successful. Then save the final dataset. The second approach is to start with the append command and the child datasets. Load the variables ID, wave, CID and CDO4I1 from the child 2 dataset. Then append the same variables from the child data from waves 4, 6, 8, 10 and 12. Now is when things get tricky. Be careful when merging the anchor data to the newly appended child dataset. Again, one option is to define a loop to run over waves 2, 4, 6, 8, 10 and 12. First, exclude the variable -merge if it exists. Then, merge many children to one anchor. This time, we need two identification variables, ID and wave, because we have already appended all waves of the child data. Furthermore, adding the command update is very important here. If you forget it, Stata might overwrite cases you have previously merged. As there are some pitfalls with this approach, we recommend using the first. However, this approach is also viable and might be more intuitive for some users. After you have matched the datasets, you can begin the data preparation process and after your analysis. This marks the end of the pairfam tutorials. Thank you for listening and good luck with your research.